Hey guys, my name is Elena. I'll show you a couple instructional strategies. And here's my Padlet. If you click on it, there are links to YouTube videos. The first one is how to solve for x. And solving for x the easy, sassy way. Solving for x has to be simple. Solving for the unknown is the basis to progress into math and sciences. Yet so many, even high school students, struggle with simple equations. The most common way to teach solving for x, especially in the United States, is balancing equations from both sides. However, it creates a lot of clutter and it leads to a lot of mistakes, especially when the equations become more complex or when you get into like physics and have more complicated equations. In most European countries, solving for x is introduced early, around grades 3 or 4. Since solving for x has to become innate, it has to become like a second nature, it is taught very simply. Prior knowledge of how to add and multiply the negatives is a must. Prior knowledge of order of operations is also a must. And here's the YouTube link to my first video.
For x the easy way. X plus 7 equals 12. Keep x on one side, everything else on the other side. 12 is already on the other side, nothing changes. 7 goes to the other side and becomes reciprocal or opposite. Instead of add 7, we'll subtract 7. X equals 5.
As you can see in these equations, the first equation, x plus 7 equals 12. Plus 7 goes to the other side. Instead of plus 7, it becomes minus 7. In the second equation, it's minus 3 equals 8. Minus 3 has to go to the other side, so x is by itself. Instead of subtract 3, when we get to the other side, it will become plus 3.
Solving for x with multiplication on fractions. 4 over 1 is equal negative 4 over 3x. We want to keep x on one side, everything else on the other side. 4 over 1 is already on the side, nothing changes. Negative 4 over 3 goes to the other side. As it does so, it changes. If it's multiplied by negative 4, it becomes divided by negative 4. If it's divided by 3, it becomes multiplied by 3. 3 was on the bottom in the denominator. When it went to the other side, it became on top in the numerator. Negative 4 was on the top in the numerator. It became on the bottom in the denominator. If you solve, you get negative 3 equals 2x, or x equals negative 3.
As you can see on this example, we have to get rid of negative 1 over 4, so x is by itself. And we just do opposite. Negative 1 will become on the bottom, on the other side in the denominator, and 4 will go on top. 4 will come on the top. So you get negative 16. Instead of balancing from both sides, it's just easier and less cluttery visually. Now, this example, negative 4 was on top here, and it went down when it jumped to the other side, and 3 went to the top. And again, it's less cluttery when you don't have to balance from both sides. Okay. Oops. All right. So next slide, we will talk about shortcut to cross multiplication and finding percent using proportions. We all know cross multiplication, kind of like a butterfly method, but I'll show you a little shortcut. And it is also in the YouTube video.
Six over x is equal to 3 over 4. To solve for x, a little shortcut. X equals fraction line. Whatever is diagonally across from x, in this case it is 3, goes on the bottom in the denominator. The other two numbers multiply on top in the numerator. You can do any numbers or variables. A over b is equal to x over c. To find x equals fraction line. Whatever is diagonally across from x, in this case it is b, goes on the bottom in the denominator. The other two multiply on top in the numerator.
As you can see in this example, if we solve for x, whatever is diagonally across from x, which in this case it's 3, it will become on the bottom in the denominator. 6 and 4 will multiply on top. And this is just a shortcut instead of doing butterfly method. It becomes important when we talk about proportions and finding percentages using proportions.
Now, once you know how to do criss-cross multiplication, especially the shortcuts, I'll show you how to do percentages. If we have 40 cars and we need to find 15%, you can remember to multiply by 0.15. But if you forget, you can create a formula. Put your cars on top and percentages on the bottom. We have 40 cars. The percentages go on the bottom. All the cars that we have is always 100%. Equals. We're trying to find 15%. Our percentages go on the bottom. How many cars is that? We don't know. X. X equals fraction line. Whatever is diagonally across from x, in this case it's 100, goes on the bottom in the denominator. The other two multiply on top. You actually get 6. That's 6 cars.
In this way, you don't have to think about what to multiply by what and what to divide by what. It is also very useful when you don't know the percent.
But if you have
like this,
25 cars, at this time you need to know what percent 6 cars out of 25 cars. You can think logically, or you can create a formula. Cars, let's put them on top. Percentages, we'll put them on the bottom. 25 cars, that's 100%. That's all the cars we have. But we're trying to find 6 cars. What percent is that? Cars go on top. 6 cars. What percent is that? We don't know. X. X equals fraction line. Whatever is diagonally across from x goes on the bottom in the denominator. 25 in this case. The other two numbers multiply on top. You get about 24%, which makes sense. 24% out of 25 cars is about 6 cars.
This way you don't have to think what to multiply by what to divide by what.